Good morning, students. This is Anjali, Assistant Professor, Department of CSE AML, IARE, Hyderabad. Today's our topic name is hypothesis testing. But before moving towards our main topic, we will recall our previous topic. In previous class, we have seen confidence interval, about confidence interval. Interval means it's showing as a range. Interval is showing it's a range. But confidence interval, that means you are deciding a range, you are getting a range confidently, and that confidence value should be 95%, 99.7% or 99%. This value should be like this. So it is a range where you are finding out some range, you are finding out the range for the unknown population parameter. Unknown population parameter. And you know that the population, what is population and what is sample? Population is showing as a group and sample is a particular group. Sample is particular group. So whenever you want to find out the confidence interval, so at that time it will show the some range on the basis of unknown population parameter, and sometimes confidence interval is used to find out used to affects on the sample size, then sample variability. This will affect on this. Again, then confidence interval we can find out by using the sample mean. By using sample mean. First you have to find out the mean then you have to find out the z-score, then you have to find out the t-test. So every time this value you have to find out. Again, for finding out the confidence interval you need the standard deviation also. Standard deviation, number of observation, and by using these, you have to find out lower bound and upper bound. But when you have a standard deviation known, so at that time you can use z-score. Standard deviation known. But when you have a standard deviation unknown, so you can use t-test value. So every time you have to find out your valuation, your population parameter is known or unknown. If your population parameter is known, then you have to convert it into a known parameter, then you have to solve it. This is all about the confidence interval. And then now we will move towards our main topic hypothesis testing. The contents are hypothesis testing, level of significance, p-value, types of hypothesis testing, and hypothesis testing steps. Now we will see one by one. What is hypothesis testing? Hypothesis testing is a statistical tool that is used to identify if the results of an experiment are meaningful or not. So, hypothesis testing is telling us that you have to identify whatever you got the result, that result from the experiment, that result is meaningful or not. And that involves the setting up null hypothesis and alternative hypothesis. Actually, hypothesis, when you are doing the experiment on the hypothesis testing, so at that time, you have to check your result is meaningful or not, and this will set up some null hypothesis and the alternative hypothesis. These two hypotheses always will be mutual exclusive, and this means if the null hypothesis is true, then the alternative hypothesis is a false. Or we can say if your alternative hypothesis is true, then your null hypothesis false. That means that condition will be vice versa. For example, we can say that hypothesis is setting up tests to check if a new medicine works on a disease in a more efficient manner. So here you can check your any any medicine is working for particular disease or not. You can check that one. And hypothesis testing is a type of statistical analysis in which you put your assumption about a population parameter to the test. This means it's saying that we know that the hypothesis testing is a statistical analysis, but we will assume our guessing. We will find out, we will consider our guessing on the basis of the population parameter for the testing, and it is used to estimate the relation between the two statistical variables. Let's see some example of the statistical hypothesis. For example, a teacher assumes that 60% of his college students come from the lower middle class family. This is assumption. What we are doing in hypothesis, we are considering some results, and we were checking whatever we got the results that are correct or not. Then again we can say doctor believes that 3D. That 3D means diet, dose and discipline is 90% effective for the diabetic patients. It's just assumption. Now that you know that about hypothesis testing, just we will see that two types of hypothesis testing in statistics. That means hypothesis testing is saying that whatever you got the result, whatever you are guessing, that result is meaningful or not, how much percent your result is correct or not, all these things we have to test. So we have seen two examples. Just a teacher assumes the 60% of college students are from the lower middle families, and the doctor are believing on the 3D, which are 90% effective for the diabetic patients. So on that basis, there are two types of the hypothesis testing. These are null hypothesis and another one is the alternative hypothesis. First we will see null hypothesis. Null hypothesis is the assumption that the event will not occur. That means in null hypothesis, it will show that whatever you have done assumption, that assumption will not occur. And a null hypothesis has no bearing on the study's outcome unless it is rejected. And for this null hypothesis, we can show by using the H0, and it is the pronounced as H0. And a null hypothesis is a concise mathematical statement that is used to indicate that there is no difference between the two possibilities. Null hypothesis is showing that there is no difference between two possibilities. That means we can say that there is no difference between certain characteristics of the data. We didn't get any different characteristics of the data. This hypothesis assumes that the outcomes of experiment are based on the chance alone, and this testing is used to conclude if the null hypothesis can be rejected or not. Suppose an experiment is conducted to check if girls are shorter than boys at the age of 5. That means they are just doing assumption. They are finding out. So that is your hypothesis testing. Null hypothesis will say that they are the same height. At the age of 5, they are the same height. This null hypothesis will say. That means it's not occurring any event. It's not occurring any event. That's why it's a null hypothesis. Then alternate hypothesis. The alternate hypothesis is a logical opposite of the null hypothesis. And it is used to show that observations of experiment are due to some real effect. The acceptance of the alternative hypothesis follows the rejection of the null hypothesis. H1 or HE is the symbol for it. For alternative, we can show that as a H1 or we can say as a HA. And the alternative hypothesis would be that girls are shorter than boys at the age of 5. In null hypothesis, what was the result? They have a same height. Girls and boys have same height. But in alternate hypothesis, it's showing that girls are shorter than boys at the age of 5. That means they are totally opposite of the null hypothesis. Let's understand. A sanitizer manufacturer claims that its product kills 95% of the germs on average. To put this company claim to the test, create null and an alternate hypothesis. If when you are doing a null hypothesis, so what is the average? 95%. And alternate hypothesis, it's showing the average less than 95%. So null hypothesis, it will not occur any different event. But alternate hypothesis will occur different event, it will change your result. Then another, we can take example, let's understand. Null hypothesis states that probability of the show of heads is equal to the likelihood of the show of tails. In contrast, we can say alternate theory states that the probability of show of heads and tails would be different. In alternate, probability of heads and tail, it's changing. But in null hypothesis, that values are not changing. So both are equal. That means we have seen that we have find out the coin is fair or not. This is your hypothesis test. Now we will see that simple and composite hypothesis testing. Both simple and composite hypothesis testing are depending on the population distribution. Which type of you are using the population. And now you will classify the statistical hypothesis into two types. First is a simple hypothesis and another one is a composite hypothesis. And simple hypothesis specifies an exact value for the parameter. Simple hypothesis will show that exact value for the parameter, and composite hypothesis will show that a range of the values. In simple, exact value. In composite, it will show the range. Let's say example. A company is claiming that their average sales for this quarter are 1000 units. This is an example of the simple hypothesis. Why we are saying that it is simple hypothesis? Because it is showing one value. It is showing the exact value. And suppose company claims that the sales are in the range of the 900 to 1000 units. So it is the example of the composite hypothesis. That means why we are saying it is a composite hypothesis, because it's showing the range. In composite, we are showing the range. In simple hypothesis, we are showing the exact value. Now we will see one-tailed and two-tailed hypothesis testing. The one-tailed test is called the directional test. Consider critical region of data that would result in null hypothesis being rejected if the test sample falls into it. And inevitability, meaning the acceptance of the alternate hypothesis. And in a one-tailed, critical distribution area is a one-sided. That means one-tailed means your result will going through only one side. It's totally in the one-sided, meaning test sample is either greater or lesser than a specific value. Let's see, we will take the example 50. Just we will consider one number 50. Now, we have to show the one-tailed. The value will be either greater than 50, either less than 50. But it will not equal to 50. So, if it's going like this, so we can say less than 50. Otherwise, if it's going to this greater than 50, but that means your result will be is totally one-sided. And this test sample is either greater or lesser than specific value. This 50 is your specific value. And in two tails, the sample is checked to be greater or less than varying range of values in two-tailed test, implying that the critical distribution area is a two-sided. That means here, now here your values, your result will be two-sided. Now again we will take 50 as our value. Now your result will be go in both sides, either greater or either less. That means your result is going into two sides. That's why it is a two-tailed test. And if sample falls within this range, the alternate hypothesis will be accepted and the null hypothesis will be rejected. Why? Because we are getting the one range. For example, suppose H0, we have H0 mean 50, H1 mean not equal to 50. According to the H1, mean can be greater than or less than 50. And this is an example of two-tailed. Just now we have seen that according 50 as our mean. So, according to H1, either greater than 50 or less than 50. In similar manner, if H0 mean greater than or equal to 50, then H1 mean less than 50. And here the mean is less than 50, it is called a one-tailed test. Now, one-tailed hypothesis testing. One-tailed hypothesis testing is done when the rejection region is only in one direction. And it can also be known as the directional hypothesis testing because the effects can be tested in one direction only. And this type of testing is classified into right tail test, or we can say left tail test. Now, right tail test hypothesis testing. A right tail test is known as the upper tail test. And this test is used to check whether population parameter is greater than some value. And null and hypothesis test for this test is given as H0 is your population parameter which is less than or equal to some value. H1 is your population parameter which is greater than some value. And if the test statistic greater than value than the critical value, then your null hypothesis will be rejected. Now, this is your right tail testing. This is your bell-shaped curve. Here you can see that null hypothesis is rejected. And your answer is getting, your null hypothesis is rejected from the right side. That's why it is a right tail hypothesis testing. Now, left tailed hypothesis testing. Left tail test is also known as lower tail test. And it is used to check whether population parameter is less than some value. And the hypothesis for this hypothesis testing can be written as H0 is a population parameter is greater than or equal to some value. H1 population parameter is less than some value. Here you can see population parameter less than or equal to some value as a H0 and H1 is a greater than some value. But in left tail, the H0 means population parameter is greater than or equal to some value and H1 is your population parameter is less than some value. That means the null hypothesis is rejected if the test statistic has value lesser than the critical value. So you can see that your hypothesis test is a lesser than value. It is a test statistic is a lesser value. Your value is lesser than your critical value. That's why we have to reject null hypothesis, and this is your left tail hypothesis. You are rejecting H0. Now, two-tailed hypothesis testing. In this hypothesis testing method, critical region lies on both sides of the sampling distribution, and that is known as non-directional hypothesis testing method. The two-tailed test is used when it needs to be determined if the population parameter is assumed to be different than some value. Just hypothesis can be set up as follows. H0 means population parameter is equal to the sum value, and H1 is showing the population parameter not equal to sum value. And the null hypothesis is rejected if the test statistic has value that is not equal to the critical value. This is your two-tailed hypothesis testing. Here, this side, your null hypothesis is rejected. Now, type 1 and type 2 error. What is meant by type 1 and type 2 error? The type 1 error can occur when your sample result reject by the null hypothesis despite being the true. And type 2 error means it will occur when the null hypothesis is rejected when it is a false, unlike type 1 error. For example, suppose a teacher evaluates the examination paper to decide whether a student passes or fails. Just the teacher is evaluating the examination paper by deciding student passed or failed. Now H0 is showing that the student has passed, and H1 is showing that the student has failed. That means type 1 error will be the teacher failing the student, that means rejecting H0, although the student scored the passing marks. Although that value is true, still that H0 is rejected. And type 2 error will be the case where teacher passes the student, although the student do not score the passing mark. That means your H0 is not rejecting. Either your H1 is true. Now, level of significance. The alpha value is a criterion for determining whether the test statistic is significantly significant. And in statistical test, alpha is representing acceptable probability of a type 1 error. Because alpha is your probability and it can be anywhere between the 0 and 1. In practice, the most commonly used alpha values are 0.01, 0.05 and 0.1, which is present a 1%, 5% and 10% chance of a type 1 error. That means we can say it's rejecting the null hypothesis when it is in a fact correct. Now we will see the p-value. What is p-value? A p-value is a metric that expresses the likelihood that an observed difference could have occurred by chance. And the p-value decreases, the statistical significance of the observed difference increases. If p-value is too low, you reject the null hypothesis. Here, you have taken one example in which you are trying to test whether new advertising campaign has increased the product sale. And the p-value is the likelihood that the null hypothesis, which states that there is no change in the sale due to the new advertisement campaign, is a true. If the p-value is 0.30, then there is a 30% chance that there is no increase or decrease in the product sale. And if p-value is 0.03, then there is a 3% probability that there is no increase or decrease in the sales value due to new advertisement campaign. And now, the lower the p-value, there is a chances of the alternate hypothesis being true increases, which means that new advertisement advertising campaign causes an increase or decrease in the sales. Let's understand the p in detail. In hypothesis testing, p-value is used for indicating whatever you got the result after conducting a test that are significant or not. If it indicating the probability of making an error in rejecting or not rejecting the null hypothesis, this value always a number between the 0 and 1. And the p-value is compared to your alpha level, or we can say significance level. And the alpha level can be defined as an acceptable risk of the incorrectly rejecting the null hypothesis, and the alpha level is usually chosen between 1% to 5%. Now there are types of hypothesis testing. Selecting the correct test for performing hypothesis testing can be confusing, and these tests mostly are used to determine test statistic on the basis of which the null hypothesis can either rejected or not rejected. And some of the important tests are used for the hypothesis testing. Now first one is hypothesis testing, Z-test. A Z-test is a way hypothesis testing that is used for a large sample size. We can say that n is greater than or equal to 30, and it is used for determining whether there is difference between the population mean and the sample mean when the population standard deviation is known, and it can also be used to compare the mean of two sample, and it is used to compute the Z-test statistic. And one sample, when it is one sample, then you can use a z is equal to mean minus mu divided by sigma upon under root n. When you have two samples, then your z is equal to x1 minus x2, mu1 minus mu2 divided by underscore sigma 1 divided by sigma square upon n1 plus sigma square divided upon n2. This is your formula when you will use the Z-test, so you can use. Then hypothesis testing, T-test. The T-test is another method of the hypothesis testing which is used for small sample size. That means that sample size will be n less than 30. And it is used to compare the sample mean and the population mean. The population standard deviation is not known. That means this is your population parameter is unknown. Instead, the sample deviation is known. The mean of the two sample can be compared using the t-test. When you have to find out you have one sample, then t is equal to x bar minus mu upon s divided by under root n, and when you have a two sample, this is your formula, so you can use when you have two samples. Now hypothesis testing, chi-square. The chi-square test is a hypothesis testing method that is used to check whether the variables in population are independent or not, and it is used when the test statistic is chi-square distributed. The basic idea behind this test is to compare the observed values in your data to the expected values. You have to compare your observed values and your expected values with each other. That you would see if the null hypothesis is true. And there are two commonly used chi-square tests are chi-square goodness of fit test and chi-square test of independence. Both tests involve the variables and that are divide your data into some categories, and this table is showing the two tests. Chi-square goodness fit test and chi-square test of the independence. Number of variable. In goodness of fitness, it will use only one variable, and test of independence, it will use two variables. What is the purpose of the chi-square goodness of fit test? It will decide if one variable is likely to come from a given distribution or not. And in chi-square test of the independence, decide if two variables might be related or not. Just we will take one of the example of the goodness of fit test. Decide if bags of candy have the same number of pieces of each flavor or not. And in independence, decide if movie goes decision to buy snack is related the type of the movie they plan to watch. Then hypothesis in example, H0 proportion of flavors of candy are the same, and Alternate hypothesis is showing the proportion of flavors are not the same. When we are talking about the independence, then H0 is showing the proportion of people who buy snack is independent of the movie type. And alternate hypothesis is showing that the proportion of the people who buy snack is different for different type of movies. Now we will see the decrease of the freedom. The number of categories -1. In our example, number of flavors of candy -1. And when we are talking about the chi-square test of the independence, then number of categories for first variable -1, then multiplied by number of categories for second variable -1. In our example, number of movie categories -1 multiplied by -1 because snack purchase is a yes or no variable, and that means 2 minus 1 is equal to 2. Now we will see some steps of the hypothesis testing. So hypothesis testing can be easily performed by 5 steps, and these steps are very important for the hypothesis and for identifying the right method for the hypothesis testing. So there are some basic steps. First step is set up null hypothesis by correctly identifying whether it is left-tailed, right-tailed, two-tailed hypothesis testing. That means in first step, you have to set up first a null hypothesis by identifying whether your test is left-tailed, right-tailed or two-tailed hypothesis testing. After getting all these things, you have to set up for the alternative hypothesis. Then in third step, you have to choose correct significance level. That means alpha, and you have to find out the critical value for your test. After getting a critical value, you have to calculate the correct test statistic. Z, T or X and P value also. And in step 5, you have to compare the test statistic with your critical value or compare the P value with alpha for arriving your conclusion. We can say, in other words, decide if the null hypothesis is to be rejected or not. That means first you have to set up your null hypothesis test. After that, you have to decide your testing is in left-tailed, right-tailed or two-tailed. After that, you have to set up alternate hypothesis test. Then you have to choose the correct significance level, and you have to find out the critical value. After that, you have to calculate the correct test statistic for Z, T or X and P value. And then you have to compare all the statistics with each other for getting a particular conclusion. That means whether we have to delete, we have to reject or not our null hypothesis. Now we will take the hypothesis testing example. Suppose a researcher claims that mean average weight of men is greater than 100 kg. Mean greater than 100 kg. With standard deviation 15 kg. With standard deviation 15 kg. Now 30 men are chosen with average weight 112.5 kg. 30 men, average weight 112.5 kgs. Using hypothesis testing, check if there is enough evidence to support the researcher's claim. And here confidence interval is given as a 95%. Now we will go one by one step. First step, this is example of right tail test. Set up the null hypothesis H0 and our mu is equal to 100. Then step 2, you have to set for the alternative hypothesis. This is given by mu is greater than 100. Now step 3, as this is a one tail test, your alpha value is 100% minus 95%, that means it is our 5%. This can be used to determine the critical value. And this, for finding out the critical value, 1 minus 0.05%. So our critical value is 0.95%. And 0.95% gives our area under the curve. Now using the normal distribution table, the area 0.95 is at z is equal to 1.645. And a similar process can be followed for t-test. And the only additional requirement is to calculate degrees of freedom given by n minus 1. Now calculate the z-test statistic. This is because sample size is 30. The sample and population means are known along with the standard deviation. So now you have to put all this value in this formula and you will get the 4.56. Then step 5, in step 5 you have to find out the conclusion. So we got the 4.56 is a greater than 1.645. The null hypothesis can be rejected. This is all about the hypothesis testing. These are your references, so you can refer these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.